So in this video, we're going to go over lab 1, and this is a exciting new chapter in the course because this would be the first video where we go over a lab assignment that will be for credit. Okay, let me go over, okay, let me just blow this up. Okay, so here, if you're on your Prairie Learn screen, you can see that I've added lab 1, and what we're gonna do is write functions. If you have any questions about the lab policy from Prairie Learn, it will directly link you to the policy on the web page here. So so just as a refresher, we're gonna have 8 labs in this class. If you go to the syllabus, you will see that labs are, I think, 10% of the grade overall, and we will go over these labs together in these videos, so you can pull up RStudio and work on them with me at your own pace. So this will be this lab will be implemented on implemented on week 2, and will be due on Thursday, September 7th at 11:59 for full credit. So you have a little bit over a week to complete it, and you're seeing the solution with me in this video. Okay, so what we're going to be doing is writing functions, and let's just click here, the area of areas of shapes. Okay, so I'm going to just minimize this. Okay, so I have on the side here, my side when I have RStudio up, I am in the Stat385 R project, and you can of course see the file, some of the folders that we have last time. So these are just things that exist on my computer that are like course detail, or like things necessary for creating the course in the course webpage, so you won't necessarily see this stuff. Okay, so I'm going to create a new folder, lab 01. Did that work? Okay, good. And I'm going to go in here. Okay, so areas of shapes. So in these labs, I know that like right now, this one's going to be pretty simple. We're going to calculate the areas of rectangles, triangles, and circles. But nonetheless, it's important to take our time, read what's going on in these in the lab prompt, make sure we do the correct thing, and then in RStudio build it, test it, and then submit it to Prairie Learn. Okay, so I just want to make sure. Okay, so what we want to do is write all requested code in an R script named shapes.r. Shift N. I'm gonna just call that shapes.r in lab 1. Okay, and we want to write a function named calc area rectangle. Okay, of course I just like to have like one line space there. Okay, so that takes on 2 input arguments: length for length of a rectangle, L for length of a rectangle, H for height of a rectangle. Okay, L and H. Okay, function. And I can just write it like this. To be extremely clear, I'm going to add a return here, which is something that occasionally I will do. Sometimes when I work fast, I'll just the last line that is left not that isn't being stored into something else will get returned automatically. But just to be clear, we'll just have return. Okay, so here's our function. All right, so calc area rectangle. You can see we added it to our global environment. Okay, actually, you know what? I was just going to copy it, but now let's test it. I can start typing it, and you can see that it suggests, after I've inputted a few characters, it suggests the function from the global environment. I can hit tab to specify the first argument, and I can press tab again to specify the second argument. So let's see what it does. Okay, command return. Okay, so seems like it's doing the right thing. I can change things up. Yeah, looks pretty good. Okay, so that's function 1, calc area rectangle. Okay, so now calculate area of triangle. Okay. So it's going to be a function that takes on two arguments, base of the triangle and height, where base is specified by b and h is specified, or sorry, base is specified by b, height is specified by h. Okay. Oops, we don't want any values. Oh my gosh, what am I doing? Okay. B times h, 0.5 times b times h. Return. Okay. Command enter. Added it to our global environment here. So now I have two choices. I'm going to go down, calc area triangle, b equals 5, h equals 5. All right, looks pretty good. Try it again. Okay, seems to be working fine. And then last but not least, calc area circle equals function. Okay, one argument r. All right, so I think that we did this earlier, and then we had the argument radius last time, but no matter. Okay, so if I remember from geometry in the previous video, this will work. Okay, so recalling that r has a built-in symbol for pi, which if I, check this out, if I highlight it and then hit the run command and my computer command return, then it will just display the value directly. I'm like running that specific quantity right here. So that's pretty cool, so we can keep doing that. Okay, fun. Okay, so, all right. And let's see how it works. That should just be pi, 4 pi. Okay, looks good. Okay, so shapes.r, got it. Okay. So I think that's everything. So let's see, can I just, all right. Okay, I can't, maybe you can drag it on your, here we go. No, okay, we'll just do that. Okay, so it says that it received the file. Oh, good, show some of the contents. Save and grade. Okay, looks like it's gonna take a little minute. All right, let me go. Man, mine. Okay, great, 100%. Good, and you can see all of the feedback. That is the things that it checks for in Prairie Learn. Okay, good. So now we're 25% the way done. Okay, I'm gonna close that. And then this is a fancy way to clear the global environment. You could just go right here and do it. Okay, let's go to Kelly criterion to determine bet size. All right, I'm not a gambler. I don't really like gambling too much, but I know that it's a very, interesting topic for people, but also just an interesting topic in general for like probabilists and economists. Has a rich history and its overlap with statistics, and has played a role in motivating some of statistical theory and economic theory as well. So it's something that nonetheless is interesting to work on when we're doing coding exercises, because it's it's kind of something where we can see some value in it, and it has a rich history with these disciplines. So, okay, so what we're going to be doing is writing a function to determine optimal bet size. So we're going to write a function to calculate optimal size of a bet using this criterion, which you can, click the link of, and it'll take you to the Wikipedia page. So that's kind of pretty fun. And so this is, being very clear here that when expected outcomes are known, and you may not know these even if you are, gambling. So, there's a sort of a risk there, or maybe a better way to say it is this is an oversimplification of what you would see in reality. But anyways, so when expected outcomes are known, in particular, the probability that you will win the bet and the potential payout, then the size of the bet from your bankroll can be chosen using this Kelly criterion. And the theoretical benefit of this is that by choosing your bet size in this way, it will maximize long-run wealth. Okay, so what do I need to do here is first create an R script named kellycriterion.r. All right, so go back to R and S, kellycriterion.r. All right. So far, so good. So I want a function named kellybet. You do not have to skip a line. I don't know why I always do that. Maybe it's just so I can add comments or something down the road. But actually, you know what? Even then, if I were to add comments, I would just skip 2 lines. It's just a weird habit. Okay, anyways. Kellybet function. I don't like it. It's pretty cool that RStudio, checks for errors in real time. It didn't used to do that. RStudio has improved quite substantially over the years. Okay, so anyways, back to what we're doing. Kellybet that takes on 4 arguments. Bankroll, which is the size of the amount of funds that you have. P, the probability of winning the bet. Wager, a hypothetical amount wagered. And payout, a hypothetical amount gained if the bet is won with a wager of wager. Okay, so then the function should return the optimal bet size. Okay, great, but I don't know what the variable is for that yet. Okay, so from the Wikipedia link, we calculate the proportion of the bankroll to bet based on the following formula. So F star is the proportion of the bankroll to bet, and our function should return this proportion multiplied by the size of the bankroll, the argument bankroll. Okay, so maybe I can just write F equals P. Okay, actually I need to keep reading because I don't know what Q is yet and B. Okay, so I'm gonna just skip that actually. Okay. P is the probability of winning the bet, which is the argument P. Q is the probability of losing the bet, which is 1 minus P. Okay, that seems important, so I'm gonna just, okay. B is the proportion of the bet gained with a win. That is the payout divided by the wager. Okay, B equals payout divided by wager. Okay. Okay, so now I have Q, I have B, and P is given as an argument. So I can write F equals, you know what? I don't think I need to actually declare it. I can just do bankroll times, in parentheses, P minus Q divided by B. Okay, and you can, if you want to space that out or add more parentheses, perhaps we should be a little bit safe. Okay, and we want to return that. Okay, so, there's multiple ways to write this function. I chose to, declare things internally. Perhaps it's quicker no, this is fine. Okay, let's save to global environment. And this function, or this prompt actually provides some test cases. So let's see. All right, good. And good. No. Ooh, well, I shouldn't say good. Okay, good and good. Okay, so we've matched on the test cases. Okay, let's just try something out here. Okay, so let's say the wager and the payout is exactly the same, so it's an even money bet. I think that if probability equals 0.5, then this should suggest betting absolutely nothing. There's no opportunity to win in the long run in this case, or lose. And that's what we get. Okay, good. Just make sure that this follows basic intuition. If I increase P, the probability of winning, then it should suggest that I bet some money. Okay, good. And if I decrease the probability of winning in this case, then it should be negative. Interesting. So that should mean that you would want the opposite of this particular bet. If the probability of winning is 40%, on the other side, the probability of winning would be 60%, which is just the case that we were just in. Okay, so there's some nice symmetry here. Okay, cool. All right, so I'm pretty happy with this. Is there anything else I need to do? Kelly bet. Okay, Kelly criterion, Kelly bets. All right, let's try it out. All right, awesome. 2 for 2, which should do well at the problems, the lab problems that I'm presenting to you. But nonetheless, still fun to get stuff right. Okay. It's not, even though I've looked at these, it's still not guaranteed in live coding. All right. Function, elo rating. Okay. Give me 1 second. I'm just gonna get started again. Let's just clear the global environment, get rid of everything. Starting over. Okay. So we're gonna write a function to calculate the update as a part of an elo rating system. All right, cool. Wikipedia page, lots of quantities here. All right, so elo system, it originated as a rating system for chess players, but it's been expanded to all kinds of stuff. You can read on here. It's used in like video game systems and to find expansions to elo are used in video game systems to sort of optimize play in those games, trying to match people for competitiveness. Or I shouldn't say necessarily maximize for competitiveness. I should say that they use it, that would be the intention that they would report. That would be the advertisement, but it'd be using it to maximize your enjoyment in the game. So maybe if you're a high elo player who takes a few hits, they may try to match you with a lower elo player to build you up so that you don't just leave the game. I don't know. I don't know the game theory behind it, but there's all kinds of research in that direction. We actually, David Dalpiez, myself, and some students in our in this collaboration with the Chicago Cubs used like a double elo system for a lineup of batters versus a pitching staff inside of a seasonal simulator. So that was kind of a fun project to work on. But we did use like an elo type thing to do that. So elo is I like it. Okay, so what do we need to do? We need to write all requested code in an R script named elo.r. Okay. And let's write a function named elo update. Okay, and the function takes on 4 arguments: the rating of player A, the rating of player B, player A's score for the match, and K, which is the K factor of the rating system. It's just this kind of governs how much movement there is, how much the ratings of each of the players move between the matches. The more you increase this, the more like movement you get. The less the smaller the number you give it, the more stable the ratings are going to be. So you want some sort of balance in between those two things. And classical ELO, based on the calculations that are in the Wikipedia page, suggests the value 32. Okay. All right, so the function should return the rating of player A after the match. Okay, don't know what that is yet. Oh, here it is. From the link above, the version of the update equation will use this. So you start with, so this from player A's perspective, it starts out with an initial rating. There's going to be a score for the match, and then there's an expected outcome for player A against player B. So if score beats expected outcome, player A's rating will update based on how much that score beat the expected outcome scaled by the K factor. All right, so this is, okay, so we have rating as an input, K as an input, S and SA as an input as well. So we need this expected outcome. All right. Let's see here, but let's read all this. The updated rating for player A, which the function should return. Okay. And then RA is the initial rating, K is the K factor, SA is the score. So in this function, the score can either be 0 if player loses the match, 1 if player wins, and 0 if the match results in a draw. So this isn't going to get too tricky. If you were to code this in some sort of try to catch all the things that the user could do that are silly, then you would probably try to, if these are the outcomes that you cared about, you'd probably build in test cases inside your function and make sure that it returns proper values. We're not there yet. This is getting further down the road. But anyways, we're not going to, under the hood, the auto grader isn't going to throw crazy values at you. All right. So the expected outcome should be calculated as follows. And this is just from the Wikipedia link. Follows this sort of like logistic type function. And then basically the idea is that based on how they, based on this like logistic type curve, you can pull out this value of K equals 32 so that you get this sort of like nice balance of updating and stability as these matches keep coming in. Okay, anyways, let's get to it. EA equals 1 divided by 1 plus 10. Scrunch it. Okay, looks like we got RB minus RA divided by 400. Okay. Okay. So now we go to, you can store it if you like, the output, and then return the value, or you can just make the calculation and have it return it. Okay, so just to demonstrate, we'll call it, let me just R sub A new equals R sub A, so I'm using this formula here, plus K times S sub A minus E sub A. Okay. message here. Okay, anyways, let's see here, and then return. Okay, so the error message went away. Well, okay, let's go back and see what that was. Okay, it's gone. All right, so let's try it. Okay, so we have some test cases. Wait a minute. I seem to recall. That's right. I skimmed it, but I didn't say it out loud. It's convention for the new value to be rounded. Okay, so round. All right. Now let's try it. Almost, that would have been a mistake. Okay. Let's see what we get. Oh, did make a mistake. Oh, default value of 32. All right. See, live coding my own problems and can't shoot. All right, got it right. 1620. Good. So here we started with, the idea was that we started with a 1600 rated player. I think a new player would have a value of 1500. So this player is, decent. And then they faced a very good player, or sorry, I should say just a better player, and they beat him. So they got a lot. So if the K factor was 32, they got 20 points added. So they got, the majority of those points added to their score. Okay, since that was more of a matchup that wasn't expected. Okay, awesome. So let's try this one. So now we have a player, a really good player, facing a slightly worse player, and they tied. And we have a pretty volatile K factor. All right, cool. Okay, we got the value, 2196. Let's do, just for fun, let's try 1600. Okay. Is it 16? Is it just going to be 16? Is it going to be 16? Good guess. Okay. So the idea here is if you face the same player, or if you place, if you face a player of the same ability and you win, then you just get half the K factor. Seems to make sense. Okay. What happens if you tie? Does it just not update? Okay. Cool. All right. Fun. All right, so I think this is good to go. All right, so yeah, we properly tested it and it seems to be pretty good. Now, if you want to be clever or just use less lines, because that's a thing, you could just, it could get a little bit cumbersome to write this all in one line, but you could skip this declare here and just have it return this quantity. Okay, so if you want, an added challenge, you could do stuff like that. All right, so we have it saved. Okay, drop file, elo.r, check it. All right, awesome, works. Okay, so you can see that there's some interesting test cases here. Oh, and some random inputs. Nice. All right, so one more to do. Rock, paper, scissors. Okay, let's clear the global environment, get rid of this. New thing. Okay. Function that can generate rock, paper, scissors. So we're going to call it rock, paper, scissors.r. Command S, Command V, get rid of the point.r, return. Okay, we want a function named rock, paper, scissors. Okay. You can add a space if you like. I think that's, it's fine. Okay. Okay, so we want, takes on two arguments, shapes, which is going to have a default value of this character vector. So you can kind of see what's going on here with this. I'm gonna break the line. And then in players equals, with the default value equals 2. So in this case, in the video, I've increased the text size, and I have a bunch of things going on. So I decided to break the line instead of have it have a long scroll here, but you can keep it like that if you like. Okay, it doesn't really matter at this point. Okay, so let's see. The function should return in players of the shapes at random with replacement. So we want this to return, so every player is going to make a draw of rock, paper, scissors randomly, and they can pick the same one, just like in the game of rock, paper, scissors. And of course, what's going on here is that you can see that it's taking on a character vector and a number of players, so you could provide this with additional character vectors of arbitrary dimension. Okay, so, but the classical game, as I know it, is rock, paper, scissors. So that's how it's going to start. All right, so to write this function, we're going to you will likely need to know something about the sample function. So you can go here and get more details about it. But basically, you kind of have a mental model of what this game is, probably. If you don't, you can go to, I think it's a Wikipedia page. Yeah, okay. You can see here to learn more about it. Okay, so you kind of have an idea about what we need this sample function to do. So I'm going to leave it as an exercise for the reader. Okay, so sample function has 3 arguments that will be relevant here. X, vector from which to sample from, size, the size of the sample, and replace, if true, sample with replacement. Okay, so I think that we're gonna want that. Okay, so we can run the following to see how it works. All right, so sample 1, 2, 3, 4, 5. So this didn't provide any replace, or it had the default for replace, and it didn't specify size, so it's just the size of the vector. Wait, that's wild. Okay. Huh. Sample 1, 2, 3, it's supposed to be random and came back the exact same order, so I just copied it again just to make sure that, Okay, so sample 1, 2, 3, 4, 5, replace equals true, so now the 1 goes back. You can see that's drawn multiple times. Here, you can take that letters vector. We showed that letters vector earlier in class, so it's just all the letters lowercase, and we're gonna make 5 draws, replace equals true. We didn't get any repeats this time, but we could have. And then uno, dos, tres, size equals 6, replace equals true. So now we have a vector of length 3, but we want to change the size. Okay, so I think we have a good idea about what the sample thing does. Okay, so I'm just gonna, okay, sample, we wanna make draws from shapes. We want size equals, no, we want size equals in players, not 2. Replace equals true, okay. All right, so is this a game? Okay, I wanna make sure I'm doing the right thing here, sorry. Write a function, turn in players of the shapes. Yeah, okay, good, yeah, I read that, okay, good. Okay, so the idea being user specifies the elements that are going to be drawn from and the number of players who are playing the game simultaneously. And it defaults at like the classic rock, paper, scissors. Okay, let's try it out. Standard game with 2 players. Nice. You see here that this adds a comment. So this, if I run the whole thing, this isn't run. This part, it's not run. It's just so that you can write a message to yourself so that when you're working on complex tasks, you can write something to yourself or to others so that they can read and see what you're doing. So that was kind of actually useful here because although, you're sort of learning what it means to write a function with different arguments and know like what happens with default. So it's just saying that the way that we set up our rock, paper, scissors function, the defaults are the standard game. So that if I call the function with nothing specified, that should just be it should just run the function with the defaults, which in this case is the standard game with 2 players. Okay, and you can see that rock, scissors, scissors, paper, scissors, scissors. Okay, so we are getting games where we are drawing with replacement. Good. And then there's different games. Playing rock, paper, scissors, lizard, Spock with 2 players. I didn't read the Wikipedia link that closely. Don't know what this is. Okay. Cool. Rock, paper, scissors with 3 players. So this is going to, so this one just assumed 2 players playing with 5 categories. This one's going to assume the rock, paper, scissors game specified at the defaults with 3 players. Fun. Scissor, paper, rock. How is that scored? Okay, rock, paper, scissors. Here we go. Poor paper. Nice. Okay, and then frog, slug, snake with Japanese names. 3 players. Okay. Fun. Okay, great. I think that we got the right thing going here. Okay, so let's just drag and drop, rock, paper, scissors. Okay, great. So this is lab 1. All right, so feel free to, of course, I'm sure that you're working on it at the same time that I was, but feel free to work on it with me. And yeah, okay, so, all right. Yeah, so that's some basic, lots of good examples, some of the cool things that we can do with even just like somewhat simple functions, and we can implement some really big ideas like Evo systems, this Kelly criterion for betting, and even play simple like fun games and have it just generate outcomes like rock, paper, scissors, and you can see how functions can be used for repeated tasks like calculating areas of shapes and whatnot, and of course with more complicated functions we do more complicated things. All right, well, thank you for your attention, and I will see you next time. Take care. Bye.